All right, let's look at these real quick. We'll start with my 2.2 atmospheres to kilopascals. Did anybody get an answer for that? I'm sorry, say it again. 224, 2.806, 86. Did anybody else get that? All right, perfect. And then 770 millimeters of mercury to torr. It's the same. That's an easy one. Remember, millimeters of mercury and torr are the same thing. And then my last one, 30 kilopascals. I can't even say them. 30 kilopascals to millimeters of mercury. I got 200. Anybody else get 200? No. Did I do the wrong thing? Okay, let's look at that one and see what we did. Oh, I sure did. I did the wrong thing. I can already see what I did. So what did y'all get on it? Tell me again, somebody. 0.07. All right, so let's just look at that one just to refresh your memory on how to do it, so I can get my answer changed. Well, no, I have the right answer right there. Sometimes I don't know what I do. All right, so remember, you start with your given here, and then we wanted to convert it to millimeters of mercury, so I would put that here. Whatever my units were here, then they had to be the same thing down here. And then remember, these two numbers came from our pink sheet. And the 760 always went with the millimeters of mercury, and the 101.3 always went with the kilopascal. So at this point, you multiply 30 times 760, and then came back and divided it by 101.3. And you should have gotten 225.07 millimeters of mercury. All righty. Let's move on to our notes, doing Charles and Boyle's law today. All right. So we're going to our gas notes that we've been working on, and you probably want your pink sheet out also. And then when we get through with that, for my virtual students, we'll go under daily work, and it'll say for Monday 3-1. All right, so we're right here. Second page, the basic gas laws is what we're going to look at. We're going to look at 2 today. So we talked about the reason that we can apply these gas laws to gases and not to solids and liquids is because the particles are far apart, so they can be manipulated more by things like pressure and temperature as compared to either a solid or a liquid. So the first one that we're going to look at is we're going to look at Boyle's law. And this is if we keep the temperature constant. So if we keep something constant, that means it's not part of the equation. And if we do that, pressure and volume are indirectly related, which means if I increase my pressure, I'm going to decrease my volume, which makes sense. If I increase my pressure, I'm going to push the particles closer together and the volume would decrease. So the formula for that is P1, pressure 1 times V1, volume 1 is equal to P2 times V2. So we're going to look at a gas and we're going to set it under a beginning set of circumstances, and then we're going to change those circumstances and see how it's affected. The units must be the same. which I mean by that, if I had one volume in liters, the other volume would have to be in liters. Or if I had one volume in milliliters, the other one would have to be in milliliters. All right, so let's just look at one of those or a couple of those. We have 4 variables, 1, 2, 3, 4. So you're going to get 3 of them. So at the end, you're going to have to do one little division problem. That's your algebra that you'll have to do to solve for your unknown. So it says a balloon is filled with 25 liters of air at 1 atmosphere pressure. So that's what it's starting with. So 25 liters would be my volume, my beginning volume, my V1. Remember, liters or milliliters are your volume. And it starts at 1 atmosphere pressure, so that's my P1. If the pressure changes to 1.5 atmosphere, so that's my change, that's my P2. What is the new volume? So that's my V2. So once again, my formula is P1 V1 is equal to P2 V2. Yes, sir. And what? You can go look in that first black box and see if you can find one. So my pressure 1 is 1. My volume 1 is 25. My pressure 2 is 1.5. And my V2 is my unknown or my X. That's what I'm trying to figure out. All right, so there's your setup. I need to solve for V2. That has to be by itself. So that means I need to get rid of 1.5. So I divide it by 1.5 over here and 1.5 over here. This cancels out, and this is what I would put in my calculator, all of that little bit. 1 times 25. That would be your top. Get yourself an answer and then divide by 1.5. And we'll do 2 places past the decimal. So 16.67. And since we're trying to find volume, it's going to be the same units as our other volume. So what were the units for our other volume? Liters. So my units would be liters, and that would be my answer.
So whenever you divide everything,
Yeah, by the one that's with your unknown. And remember, if it's on the top here, then when I move it across the equals, and that's how it gets to the bottom. But yes, you'll have your unknown and you'll have a number, and that's what you're going to divide by, that number that goes with it. All right, let's look at one more of those, and then we'll talk about Charles's law. So this one says a balloon is filled with 73 liters of 1.3 atm pressure. So there we go, is my V1. 1.3 atm, so that's my P1. What pressure is needed to change the volume to 43 liters? So that's my new volume. So in this one, my P2 is my unknown. So once again, we're still using that same formula. So I'm going to go P1, which is 1.3, times V1, which is 73, is equal to P2, which is my unknown, times V2, which is my 43 liters. So that's my setup. I need to get P2 by itself. So what do I need to divide each side by? Perfect. 43. 43 liters cancels that out. And here I'll divide by 43. So that's what'll go into your calculator. 1.3 times 73. And then get yourself an answer and divide it by 43. I got 2.21. And what would my units be? I'm trying to find pressure. ATM, exactly. P isn't a unit. P is just saying that it's for pressure. So, but since my other pressure was ATM, then this one would be ATM. So that one is Boyle's law, and then we're going to look at Charles's law. The math is the same. You're just comparing two different things. So with Charles's law, we're holding the pressure constant. So that means that we're comparing the volume and the temperature. And the volume of a gas is directly proportional to the Kelvin temperature, which means if I increase my temperature, then it's going to increase the volume, because if I increase my temperature, I put more energy into the system, the particles spread out more and the volume would increase. Remember, on all these gas laws, your temperature has to be in Kelvin. So if you're given one, and we'll look at it in a minute, if it's in degrees Celsius, I have to add 273 to it before I can put it in my formula. So this formula is V1T2 is equal to V2T1. Notice the temperatures, they kind of seem like they're on the wrong side, but that's because of the relationship. And temperature must be in Kelvin. All right, so we'll just look at a couple of these. It says, what is the temperature of a gas that is expanded from 2.5 liters at 25 degrees Celsius? So 2.5 liters, that would be my beginning volume. 25 degrees Celsius, I can't use it in Celsius, so I'm going to go ahead and change it to Kelvin so I won't forget that. So 25 plus 273 would give me 298 K. And that was my beginning temperature, my T1. And then it said it went to 4.2 liters. So that's my V2. Let me erase this, because that's the volume measurement. So what I'm trying to find here is my T2, what my temperature changed to. So my formula is V1T2 is equal to V2T1. So now I'm just going to start plugging my numbers in because I identified them all. V1 was my 2.5 liters. T2 was my unknown, so I'm just going to leave that. V2, my second volume, was in it changed to 4.1 liters. And my beginning temperature was at 298 K. I can't put it in as 25. I have to put it in as 298 K. So what am I dividing by this time? Because remember, I need to get T2 all by itself. Yeah, 2.52. Kind of don't have enough room, but 2.52, because that is what is with my unknown, or my X. So 4.1 times 298. I'm sorry. I can't hear you. No, liters, I'm sorry. It's a liters. Can't remember right. I carried the liters with it. 2.5, I'm sorry. Did I say 2.52? Sorry. 4.1 times 298 divided by 2.5. I got 488.72. Is that what y'all got? And we are trying to find a temperature. And when you find it in the problem, then you found the temperature in Kelvin. So my units would be Kelvin. So once I change that Celsius to Kelvin, then everything will be in Kelvin if I find a temperature in my thing. Yes, sir. Yes, your unknown would be in Kelvin. The formulas? I'm gonna show you in a minute. All right, let's look at one more of those and then we'll look at our peak sheet. Move this up and make a little bit more room. All right, so what is the final volume of a gas that starts at 8.3 liters and 290K? So that's where it starts at. So that is my V1 and that's my T1. And notice that T is already in K, so I don't have to add that 273 to it. It makes it a little bit easier. And it is heated to 369K, so that's my T2. And since I wanted the final volume, that means my V2 is my unknown. So I'm just going to jot down my formula again. And now I'm just going to start putting everything in. My V1 was my 8.3 liters. My T2 was my 369K, and it was already in Kelvin. My volume 2 is my unknown. And then I go back to my T1, which was my starting, my 290K. All right, so that's my setup. I need to get V2 by itself. So what am I dividing both sides by? Perfect. 290K, and over here, 290K. That way it gets rid of this. I'm only left with V2, and then this side is what goes in my calculator. 8.3 times 369. I'd get myself an answer and then come back and divide by 290. And 10.56, is that what you got? And what are my units going to be? L, liters. Perfect. Perfect, perfect. So funny looking L, but that's an L. All right, let's take a minute to look at your pink sheet and mark these on my pink sheet. That way, when you have a test or a quiz, it'll be quick way for you to find them. I had liters because we were trying to find the volume. Yes. 10.56. Is that what you got? All right, on your pink sheet, go to the other side, not the side where it has all the gas conversions. Go to this other side. And first of all, this one is Boyle's. If you go into the section that says behavior of gases, the third one up, P1V1 is equal to P2V2 is Boyle's. You might want to mark that one. And this next one, although it looks different, is Charles's. And I'm going to take it out of the fractions. It was originally derived in those fractions, but you can take it out easily. I don't know, to be something noisy, a little bit harder if it's in fractions. So V1T2 is equal to V2T1. On this thing today. Right. So let's look at our worksheet. We all have plenty of time to get that done. Oops, somebody leave me? All righty. Let's see. Let's go to our worksheet. It's just using those two laws, and I have them separated out. Y'all believe it's already March? I said, can you believe it's already March? I can't either. I'm not gonna lie, I really didn't think that we would, with Corona, I didn't think we'd be open for that long. It is a blessing. All right, so the first set are Boyle's law, and you can see I have them sectioned out, and here's the formula. So on those, you're just gonna be using P1V1 is equal to P2V2. So we'll just go through one more of those, and then we'll go down to Charles's. if 22.5 liters of nitrogen at 748 millimeters of mercury are compressed, so that's my V1, that's my liters. Millimeters of mercury is a pressure, so that's my P1. And then it says it's compressed, so pushed together to 725 millimeters of mercury. So that's my P2. What is the new volume? So that means my unknown is my V2. My unknown, what I'm trying to find, is my V2. So now we can just start plugging in. P1 is 748. V1 is 22.5. And set that equal to P2, 725. And V2 is my unknown. I need to get V2 by itself. So I'm going to divide each side by what? 725. That cancels, and now this is what needs to go on my calculator. Okay, I will. 22.5. And go ahead and get you an answer.
No,
Okay, so you did these, you did this number times this number?
yes.
Okay, you got you an answer. Divide by yes. Divide by your 725. You got 20, what'd you say? Perfect, 23.21. And like Summer said, because we are trying to find the volume, it would be in liters. All right, there's about 5 of those, and then there's about, I think, 5 that use the other formula. So they go to the next page. Same thing, just remember there are a couple on this one, like number 7 and number 8. Oh, there's not even 5, there's only 4 on the side. Look at number 7 and number 8. Don't forget, you have to turn those 25. I mean, you have to turn that Celsius into Kelvin before you put it in the formula. So look at them. If we just jump down to number 8, if 15 liters of neon at 25 degrees Celsius, so there's my 15 liters is my volume 1, 25 degrees Celsius my T1, but I'm going to go ahead and change it. So I'm going to add 273 to it. And I like to do that so I won't forget and put it in the formula as 25 degrees. If it's allowed to expand to 45 liters, so that's my volume, the second one, what must the new temperature be? So I'm trying to find T2. So my formula V1 T2 is equal to V2 T1. And once again, we've labeled everything, so now it's just plugging it in. Volume 1, V1 is 15 liters. T2 is my unknown. Volume 2 is my 45 liters. And T1 was my first temperature I started off with in Kelvin, not in Celsius. All right, there we go. We need T2 by itself. So what are we dividing each side by? 15. Perfect. 15. 15 here and 15 here. That cancels, and then this is what I need to put in my calculator. 45 times, that's supposed to be 298. I'm really having trouble with my numbers today. Times 298. Then come back and divide by 15. And I got B2 is equal to 894. Is that what you get? And it's not B2, is it?
No.
T2. So what would my units be? Kelvin. Perfect. Okay. You have to change those two. Add 273 to them before you put them in. I think the 2 above it are already in Kelvin. Alrighty. So that leaves y'all, I don't know, I think about 8 problems or so. 7 or 8 problems left to do. Okay, good. So let's work on those and hopefully y'all can get them done. Do y'all have any questions, my virtual students?